sorry, we are going through the concept of percentage. So we know that the hundreds are percentages. So if you get 0.3, you know that it's 30%. How much is 60% of 30? So 60%, you know that it's 0.6. Yes. And with the 0.6, you multiply the 30. That's the part of the 30, yes? So you get the how much it was. Does this seem familiar to you?
Yeah. Yeah.
Yes. Do you think that this is quite something that you did before? Who thinks that it's quite something that would you have been able to do this already without this lesson?
Yeah.
Or no? Mainly, yeah, this is okay. So if you know that something costs 430 euros, but that's the 80% of the original price. So it was on sale of minus 20%, yes. So what was the original price? So then you would know that you have to multiply something with 0.8, which was the percentage in the hundreds, and the something you would mark usually with X, yes, and that would be 420. So now you have to then just solve the X, and you get something more, yes. If you divide something with a number that's less than 1, you get, of course, more than the original amount. That makes sense.
Yeah.
And of course, it has to be more than the original amount because it was only 80% of the original price. So it was on sale of 20%. You say it like that, yes? Yes. So you know how to, when you go to the sales and then you think about these things. Who has went to the sales and thought this kind of things there? Maybe everybody. Yeah? Something was produced. If something is increased by 2%, then you have to multiply it with 1.02 here. So there's 200 more. Yes. So then it's the original amount plus something more, or then you just first calculated the 2% of the original amount and add it. Yes. Also, then there was this how much smaller. This is something that I get at least mixed with. How much smaller is something, or how much larger is something compared to. So then you think that what is the actual calculation here? Like the one you compare to is the one that is dividing the number, and then you have to diminish. This is something that I really always have. What is being asked here? How much smaller is 4 compared to the number of number 5? So, okay, why would I want to? What is 20% smaller? Or if we are comparing how much larger? So then there's again the same, but in plus sign, and then you divide with the one that you compare to. Yes, you always divide the one that you compare to. Super sale. So something's been sold in 50% discount, and then you still get 60% discount. And you only have to pay 104 euros. So first, it's if it was 60% discount, so you pay 40% of the price finally, don't you? But that was only also 50% of the original price, and then you just multiply everything together. Maybe these are better to be tried than to be explained like this. Yes. So let's just go to the calculations then. So you were calculating something here. Was it the 12 that you were asking of?
Yeah.
Okay.
So then,
So what if I do that as well? Or do you wanna?
that's not, that'd be just like 100% goes to 117%. No, it's just.
The price was first increased by 5%.
Yeah.
And then is further increased by 12. So first, if it's increased, you have to put this 5% to the 1.
Yeah.
And multiply it with that. And then you still put this 12% to the 1. So at first you multiply with 1.05.
Yeah.
And then you multiply with 1.12.
Yeah.
And then final price, but there's no price. How can you calculate any price if there is no number? You have to give it the price. Now you can think about it yourself. What was the price? Yeah. There should be some number there. I'll check from the solutions what was meant. Obviously, this has been translated quite quick. Let's check from here. I don't have those. Yeah, the other solutions were there then after these. Why does this look so different? Oh yeah, because I don't have those new exercises there. It looks like it has been here 87 euros, for example. But that's just mainly the way that you do it. Yes. Okay. I think I had already, this is already showing here as well, yes. So you can even see that the solutions. So this time is to calculate these exercises. Or if you already did them, did you already do the quizzes? Did somebody already do the quizzes of this topic as well? Not yet. Yeah. So there is still quite a lot to do. Okay. So we concentrate on this.
Those quizzes, do they count to our final score?
Yes.
Yeah.
Yes, because it was here. How did I put it? I don't remember now, but let's check. It should be here. Yes. So little tests. I've been calling them little tests, or it could be called quizzes. You can get maximum 20, but I think now you can get actually a bit more because I put maybe 22. I put maybe 2 quizzes more. So you can get 10 points, but this is not compulsory.
Yeah.
But to pass, you don't need to get any. But Of course, then when all the points are calculated together, your grade gets higher when you do those. And if you don't do them, then you don't get to 5. Yeah. And then what I'm gonna do with those as well is that those ones you can do them during this course when this course is being opened, but late afterwards you can't anymore. So during this course, they are there open, but after the course, if you didn't pass or if you weren't basically here on the course at all, because this happens many times at all, as well, that the students don't participate and then they ask later on, like, what's gonna happen? I wasn't there. So then you just can go to and take the exams in the examinarium or the final exam. And then you can still pass the course. That's there always open. But then, or I can open it for you. Let's see how it goes with this course. But then that's the only work. So then I don't have to go there and try to check, did you do this and did you do that? And then somebody asks you, yeah, but I did this and I did that. And then they have problems of realizing that, like it becomes a like really big hassle with that kind of students. So then it's better that there's only one thing that they still have to do if they weren't present. Yeah. It doesn't make any sense to have something there open on the Moodle base if the course is not going. Unless it's a course that's like this kind of a, how do you say, course that you do a self-study whenever.
Yeah.
That's a different kind of a course, but it's this kind of a course that goes certain time. So the things that are there, these exercises, they are open during that course, and then the exam is open. You can do it whenever if you weren't participating actually the course when it was ongoing. So I have to, yeah, I have put there submit all assignments, but I don't know if it makes it clear that they are only open during the course. So the course, no more. Okay, but we were here and calculating whatever you need to calculate at the moment. I will go and get some water because I had a lesson before this, and I thought because I was doing the lesson as distant and it was at 8 o'clock that nobody was present. It has been this technical issue. I thought that nobody was just there,
Yeah.
But I recorded it, but like maybe if somebody even wanted to attend, they couldn't. Well,
Was it math?
no, it was thermodynamics. So maybe even nobody wanted to attend.
But it started at 8 or 8.
Yes.
Yeah. Quite heavy for a morning, but
Yeah. So I thought that maybe nobody's even attending, but like, no. I can get inverse. Okay, do you wanna ask of some of the or something else?
Could you maybe? You show me like number 16. How did you do it?
16.
Yeah.
Yeah, it must be this.
Wait, no, the one I have is 320 litres of. What am I writing? 320 litres of pesticide.
Oh, pesticide.
Yeah. Yeah, that's one.
Okay,
That's fine.
yes. This is person. Cheese. And this is 12. So you have a volume of, let's just say volume of 330 liters. And the concentration. Should be 3%. So you have to have 3% of this pesticide, yes. More pesticide was added to increase the concentration. So you want it to go up to the 5%. How much pesticide was being added? Yes. So first, there is 3% solution. So it means that of this 320 liters, 3% is pesticide and the rest most probably water, yes. So you have to first the amount or of pesticide is 3%, which is 0.03, yes, times the whole volume of the whole solution, which is 9.6 liters.
Yeah.
And then you want this to be, you want the concentration of 5%, so you want to put a little bit more. And how much do you put more? So you can, for example, do it like this, like you know that there's the volume, this is the total volume of the solution, volume of solution. Solution is this here, and of that pesticide you calculated. The pesticide is here. So you think about this the same way the next again. So the volume of solution is more, of course. So you previously had 220 liters. But now it's a bit more. So how much more we can mark it with X? This is my volume of solution now. Volume of solution is a bit more. This. And of course, I have to put it in brackets now because of that. I have now this pesticide, the 0.05%, yes. Well, 0. Here is the same pesticide thing, but I just calculated it, yes. Pesticide, I calculated it here. So now I have the pesticide, the 0.05, so 5%, a bit more of this solution whose that's volume is a bit more as well, yes. But of course it's the same increase to the volume of the solution as to the volume of the pesticide, yes. So it's the same X I put there to the tank sum. So there's more, it increases, but it only increases with the amount of the pesticide, yes. I didn't put there more water anymore because I wanted it to be more, how do you say, strong or concentrated solution. Does it make sense?
Yeah.
Was this what you were asking?
Yeah, no, I haven't added on. I've just calculated.
So you calculated some other way?
Yeah, well, I only calculated 5%. Yeah, 5% of 320. I didn't add in the extra.
Yes.
Yeah.
Okay. Yes. So this is figuring it out like this is, I don't know. Now this looks a little bit, finally it looks a little bit complicated maybe, does it? But this is, I don't know. And then just to calculate this.
Yeah.
This, how to calculate this until the end.
So,
but did you get the same result?
no.
No, so you did something, because maybe this can be taught some other way as well, but this is maybe the most simple way.
Why do you take away 6? On this.
What?
This one, like not when you're writing the other one.
The other one?
Yeah, when it's plus X becomes negative 16.
Oh, yeah. So I'll just calculate this through still. Yes. So 0.05 times 320 seems to be 16. Yes.
Yeah.
16. And then 0.05 times x is of course 0.05x. So if you have something here as a multiplier in front of the brackets, of course you have to multiply them both.
Yeah.
Both things inside the brackets. So because you didn't know how much x was, otherwise you would be multiplying some amount, but because the increased amount you didn't know, so now you have to first go and multiply both.
Substitutes.
And then you have this other side here, still as the same. And then you want to have the x's on the same side and the numbers on the same side. So here in this solution that's there, it looks like I have done so that I have first taking the x from this side to this side, of course, because I want it away. And then I have taken the 16 from this side because I want that also away. It looks like that's what has happened there.
Yeah.
But it hasn't been marked this clearly at all. So then I end up with 0.05x minus x on this side and 9.6 minus 16 on the. So on the left side now I have only the x terms with the x, and on the right side I have the terms with the number like I want it to be. So then if I take from 0.05 x, the x, you know, the whole x, of course, I get like minus 0.95x here, yes? Yes. And on the other side, I take from 9.6 to 16 out, so I get minus 6.4. So now both sides are with the minus sign. But then when I divide it with the minus 0.95, I get a plus sign on this side, of course. Minus divided by minus is plus. There. Which seems to be something like 6.7368. And this is, of course, liters. I left out here now when I was calculating the liters because maybe that would make it to look more like messy. Also, maybe in physics calculations, sometimes when you do them, if you know that the units are correct, maybe you don't mark them into the calculations always, or especially when you do with Excel, of course, there's no units, you just have to know the unit that comes.
Yeah.
Okay. So then the X can be rounded to 6.7 liters because this is with the correction of two how did you say, two numbers like yes, two significant numbers, yes. So this is how much was added. Yes, so you still added 6.7 liters there, so in total then you would have total I have 9.6 plus 6.7 liters of the pesticide, which would be 16.3. liters of pesticide in that solution.
And copy that's the.
Yes.
Yeah.
I will also scan I think the solutions that we made, I will try to scan them all there to this year. So then I just mark them the solutions that we made. For example, with, you know, like now, with the year or something of all of these.
I have the one for that row.
Okay.
I have one for the Does it show you like?
Yes. Yes. I can also come and see nitrogen core of yes. And then that was 14%. And then you get
So I calculate the percentages of those.
oh
Then add together, but that's what mine came out as, but here it says 18. So then.
okay. So you had a little bit of there, something, just maybe there's some rounding thing or. But did you get exactly the same? Did you get the same ones here?
No, this is. I don't know. Yeah, I wrote it in wrong. Yeah, my bad. I didn't write them. For some reason, I put 14% of 700 as 119. But it's not.
Okay. But there might also be, like, if you find some problems here, then you should also say, because it's not just,
No, I think it's my mistake.
yeah, it might not be 100% correct, everything there, like. How about the heat pump?
I just started that.
Okay.
The heat pump one, that should be a thermodynamic.
Yes. So how do you find this course content so far? Do you think that you're managing well with this? It's not too. It's okay,
Yeah, I think good.
or it's, yeah, because soon we will have the
Yeah.
first exam as well.
Do we have a revision class before that?
Yes.
So we just come to you to ask beforehand, like what we'd like to practice.
Well, yeah, that also that would make sense. I also made some kind of, or I gave the all of those exercises that we did to the AI, and it did some kind of said like, and it just changed some words there. It's like, well, okay, this is okay. At least it's simple.
Yeah.
And then, of course, the exam questions would be something similar to that as well.
Yeah, I think it's okay. Yes. I have confidence to go into the exam, but I don't know if I'll be so confident when I see my result.
No, but it's just like it, it's everything will be on like this level that we've been. It's not gonna be, you don't need to know anything more there. Definitely. But next week is the exam and it's the revision. Should we then tomorrow still go to the system of equations?
Next week is the exam.
Isn't it next week?
Oh. Went very fast, the time.
Yeah, that's true. I think it's the next second lesson of next week.
What is system of equations? Is that two equations?
Yes, and then you solve, it's here the next. There might have been some, I have to check also the quiz because there might be a problem. The one guy, what is it called? The one Finnish guy told that he might have found there some kind of a problem, which is completely possible. System of two linear equations. Yes. There. So it looks like this. But then here it looks, of course, horrible because there's A's and B's. But of course, you just, how does it look here? Yeah. So there's X and Y. And then you first solve one, or then you just put them together. You add them together and you solve one, and then you can solve the other. And these are actually linear equations again, because the X or Y doesn't have any power.
Yeah.
So this is an equation of a straight line. Yes.
Yeah.
So it means that if you solve something like this, it means that where they intersect, the intersection point of two straight lines.
Yeah.
Basically. But then it might get pretty complicated when if you have there a lot of something and then you're solving it, and like, so you might also, when you do this by hand, you might make mistakes quite easily. So then we are also supposed to learn one other method of solving this by Excel. And we don't actually go to the theory under it at all. Just what you would do in practice if you would have this kind of a problem somewhere in some more advanced courses. You wouldn't be calculating these by hand, most probably, if you would have the computer. But that's not something that's been tested in the exam then at all, because we don't use Excel there.
Yeah.
But it's just because I would never calculate by hand something complicated like this, because it doesn't make any sense. You just do a lot of use a lot of time and you can easily make a mistake. But anyhow, we will first learn just with a couple of exercises to do it by hand. So you know how it's done, what it means, and then how you would in practice in working life do it. Yes.
Is there a hammer technical? You know, we have the formulas.
Yeah,
Is there
the
a page
technical
for it?
formulas.
Yeah, is there a page for that? Or
I don't think so. You just have to know that
yeah,
we just learn how to, because there's nothing you can really do
yeah,
with any formula. Of course, for this Excel, how you do it in Excel, maybe it's to do with matrices and vectors.
yeah.
But we don't go to matrices or vectors on this course.
We did that on the next one.
No,
Okay. Does that come in number 3?
maths number 3.
Yeah.
But do you have maths number 3?
No. What can I do that? I could ask. Like, can I go and do it?
Most probably you can select it from some other department, but I don't know if that's done in English.
Yeah.
I don't know if they offer that in English.
Yeah.
But the matrices and the vectors that you would possibly need
Yeah.
have usually been on your department in that course where you need it. So if in that course you need this certain thing, at first it's being taught as maths, and then you go to the theory where you actually use it.
Yeah.
But I don't know how it's gonna go with this program, your program, because this is a new program. So I can't tell.
Yeah.
But of course, if you need some kind of a mathematical method, it will be some way or other be taught to you. Okay, so should we do still something on this topic? Heat pump? Does this seem clear to you, this?
Yeah.
It's pretty clear, isn't it? So I know something here. I know this coefficient of performance, which is called, which is shortened to COP. And this is 2.5. And then I also know that what it means is heat output. And this is divided by electricity to input. So this was in we can express both in kilowatt hours. Is this how you say it in English? Kilowatt hours. This is the unit that you pay the electricity.
Yeah.
So then here, if you know that the heat output that you need, so it said that how house's annual heating energy requirement is this heat output. This is 16 megawatt hours. And then this, I know it's the 2.5. So then I can, of course, solve the one there under the line. Yes, it's not difficult. This is what it asks first. Electricity input. What is it? And I can, for example, mark it with work or power. And when it's in kilowatt hours, there's the time. I'll mark it with P, which is power. So my P would be the, well, let's first put this equation here with this is P, and then I'll mark the heat output with P. This is how it usually marked. P. This is now the P letter here. Heat output. It's P. And there I now have to resolve the power, yeah? So I multiply with the power, and it goes next to the COP, which is P, and then I divide with the COP, yes. So that I get the P. Does this make sense? COP, which this was 16, and it's megawatt hours. So it's 16,000 kilowatt hours. Well, I can get it in megawatt hours as well, can't I? Whatever, it doesn't matter. I get it either kilowatt hours or megawatt hours. And 2.5, so I get either divided by 2.5, so I get either 16,000 divided by 2.5, so it would be 6,400 kilowatt hours or 6.4 megawatt hours. Yes, pretty easy calculate. And what percentage of the heating energy requirement is obtained for free? So free, so I didn't have to use like, yes. Can you understand it from here? So if you want 16 megawatt hours, and part of it is 6.4 megawatt hours, so for free, that was for free, this is the heat pump thing. You get 16 minus 6.4 megawatt hours, which would be 9.6 megawatt hours. Maybe it's not completely, you can't like see it that well, but this is how you think about it in the simplified manner, that this is what you buy. This is your requirement. And with this that you buy 6.4, you get the rest for free when you're using heat pump. So then if it asks what percentage of heating energy requirement is obtained for free, it's of course now we are in the percentage calculated. It's the same. It would be 9.6 divided by 16, yes. 9.6 divided by 16, which is 0.6, which is 60%. Which is 60%, yeah. Maybe it's not that clear to see this, that this is what we were looking for here. And then you can, of course, calculate also how much will the heating of the house cost, but this is not a percentage calculation, so there was only one. Only one percentage calculation in this one. Yes. What?
I put 16,000 at the bottom. So all my thing was wrong.
Yeah. So this is surprisingly difficult, this kind of solving of equation. It's really easy to somehow put it in the wrong way. And I think it's just that you have to think it through how it goes slowly or take a little bit of time, even if you think that it might think that it's self-evident.
Yeah.
So then it's really easy to actually mix it up and do some other completely different calculation.
I would like to confident later. I knew.
But this kind of, then you have also the, what is it called, the check one word from here. The efficiency, thermal efficiency, things like this, those are always percentages. Or basically efficiency. So how much you get something useful out of everything that you use. How much you get power that you wanted to working power with the power that you bought or you took from the network. This is a common percentage concept.
Yeah.
We don't have more that kind of calculations here now there. We could have. I could actually maybe even in the rehearsal put a couple of those.
Yeah.
It's just the same calculator basically. You just get a couple of numbers and then you just solve very simple calculation. Are we happy with the percentages now, or do you still want to continue this week? You can still also ask if we on the next lesson go to the system of equations. You can still ask if the quizzes or whatever of anything you need. Yes. Okay, should we go to eat? Are you hungry?
Didn't realize that way quite fast. I thought we were handling it so.
The math is so interesting, isn't it?
Well, yeah, for me.